Alright, so today we're going to talk about simple crosses. In other words, how do I predict what offspring are going to look like for a certain set of parents? So let's do some review real quick because again, we need to remember these various terms in order to answer these kind of questions. Alright, so I'm going to say the ability to roll your tongue was dominant. So remember, I'm going to use a big letter for the dominant trait and a little letter for the recessive allele. So which alleles I have, remember that's my genotype, and then my physical traits are going to be my phenotype. So for this particular situation, I have two big R's, going to be able to roll the tongue. Big R, little r, still going to be able to roll the tongue. Little r, this is the only situation where my phenotype is going to be the recessive because I don't have a dominant. Alright, going back to this, remember for our genotypes, we're going to use those fancy words, homozygous and heterozygous. So in this case, since I have two different alleles, I'm going to call that the heterozygous genotype. And for homozygous, I got to be able to say, do I have two bigs or two littles? So if I have two bigs, I'm going to say I'm homozygous dominant. And two of the recessives, homozygous recessive. So remember, you got to remember these words and these terms because this is how we're going to set up a lot of these problems and answer these questions. Alright, so how do I actually determine the different possible offspring? Well, I'm going to take the genotypes of two parents. So in this case, I have a dad who's heterozygous and a mom who's homozygous recessive. That's their genotypes. Their phenotypes, the dad can roll his tongue, the mom can't. Now, if you remember back to meiosis, we talked about how homologous chromosomes get split. That means that these parents are only going to give one of their alleles to their offspring, which means the dad can give a big R or he could give a little r. The mom, since she's homozygous recessive, she's only going to give a little r. Alright, so we're going to use this thing called a Punnett Square in order to figure out what the possible offspring are going to be. So inside this Punnett Square are going to be all the different possibilities for offspring. Now you notice we have 4 squares, which means each one of these squares is going to represent a 25% chance that these parents are going to have that kid. It doesn't mean that these are the 4 kids that they are going to have. It just means these are the possibilities, and this is the likelihood that they're going to have those kids. Alright, so how do I set this up? I'm going to put the alleles along the top, and it doesn't matter whether I put the dads up there or the moms up there, but it's got to be one parent on the top and one parent on the side. Then I'm just going to bring them down and bring them across. So that first kid is going to be heterozygous. Second possibility is going to be homozygous recessive, another heterozygous, and another homozygous recessive. So again, remember, these are my possible offspring and the chances that they will be born. So let's look at the different genotypes. I have a 50% chance that I'm going to have a kid that is going to be heterozygous and a 50% chance that they will be homozygous recessive. Now if we look at the phenotypes, that means you have a 50% chance that they can roll their tongue and a 50% chance that they can't. Now that, again, that does not mean that if you have 20 kids, 50% of them are going to be able to roll their tongue and 50% can't. You could have 20 kids and they could all roll their tongue. This is just a probability. Alright, so let's look at a different way of setting up a problem. We're going to say in mice, brown fur is dominant to white fur. What you should always do for all of these problems is identify what are the alleles, what are the possible genotypes first. So I've got brown fur and I've got white fur. Since I say brown fur is dominant, I'm going to use the big letter. And for white fur, I'm going to use the little because it's recessive. Now there's 2 possible genotypes that give me brown fur. I could be homozygous dominant or heterozygous. And for white, the only way I'm ever going to have that is if I'm homozygous recessive. All right, so I'm going to say what happens if we cross two individuals. When I say cross, I mean mate, two individuals who are heterozygous. So what is their genotype? They're going to be big F, little f. And what's their phenotype? They're going to have brown fur. So both of them are going to have brown fur. Both of them are going to be big F, little f. So if I set up my Punnett Square, I'm going to take the genotypes of the parents. I'm going to put them on the top and the side. I'm going to match them up. And these are the 4 possible offspring and the percent chance that they will be born. So let's look at the genotypes. I have a 25% chance that I'll get a homozygous dominant, 50% chance of getting a heterozygous, and 25% chance of getting a homozygous recessive. Phenotype-wise, though, because homozygous dominant and heterozygous both have the same phenotype, all 3 of these can give me the brown or the dominant phenotype. So I'm going to have a 75% chance of getting a brown furred mouse and a 25% chance of getting a white furred mouse. So make sure you realize that the genotype percentages and the phenotype percentages won't necessarily be the same. Alright, so to finish things off, how do I predict what offspring look like? Well, it's really, really easy. All I got to do is take the genotypes of the parents, use that Punnett Square, fill it out correctly, and I will find out what are the 4 possible genotypes, and then I can use what I know about dominant versus recessive, and I can figure out what the possible phenotypes, or what they will look like, are. And again, keep in mind, those are just probabilities and possibilities. So there we have it. How do I predict what offspring will look like based on their parents?